Isomerism. At the end of this module, you will be able to define isomerism and optical isomerism. Do you know why yogurt is sour and what causes muscle fatigue during strenuous exercise? The answer to both is lactic acid. However, the lactic acid in yogurt is different from the lactic acid that builds up in muscles. Why are there two different forms of lactic acid? Let us find out with some examples. Displayed are three pairs of compounds with each pair having the same molecular formula. Examine each pair closely. Is there any difference between the two molecules in each set? If so, what is the difference? Let us find out. Take a look at the first set. In this set, the manner or order of linking of the various atoms is different. That is, the structure of the two molecules is different. One of the molecules is ether and the other is an alcohol. In the second set, both the molecules are 1,2-dichloroethylene CH2Cl2. However, the arrangement of the chlorine and hydrogen atoms about the double bond is different. In one of the molecules, both the chlorine atoms are on one side of the double bond and the hydrogen atoms are on the other side. In the other molecule, there is one of each on either side. The difference here is spatial and not structural. The structures of the two molecules in the third set are the same. That is, the atoms are linked in the same way, but their arrangement in space is different. The molecules are mirror images of each other. The phenomenon in which two or more compounds exist with the same molecular formula but different structural or spatial arrangement of atoms in their molecules is known as isomerism. Such compounds are called isomers of each other. Displayed is a flowchart depicting the different types of isomerism encountered in chemistry. Among the sets of compounds that we just studied, the first set is an example of structural isomerism. The second set is an example of geometrical isomerism. And the third set is an example of optical isomerism.